Okay, so this little video is about compounds. Okay, so when we've got a compound, we've got something which is chemically combined, so it's got two or more different elements and it's chemically combined, and we say it's in a fixed ratio, and we're going to look at the ratios in a moment. So what we're looking for when we're looking for a compound is basically, when I look at the chemical formula, has it got more than one element or not? Okay, now we've seen a few things that come where we've got more than one atom of something but are not necessarily a compound. So examples that we've looked at before are things like nitrogen and oxygen. Now when we look at the formula here, the number 2 tells us that oxygen and nitrogen like to go around in pairs. So if we were going to draw them, we'd have 2 oxygen atoms, or similarly we would have 2 nitrogen atoms, and they like to go around in pairs. But these are still an element. When we look at the chemical formula here, we've only got one capital letter, one element, oxygen and nitrogen. Now when we're looking at compounds, we will have more than one element being involved. Okay, so it's really important that we know what the chemical formula is for the actual thing that we are trying to establish, whether it's a compound or an element. So some of the common compounds that we have looked at previously are things like water. So if we look at water, we've essentially got one oxygen atom. Okay, so one oxygen atom, and the number 2 here tells us we've also got 2 hydrogen atoms. So we've got 2 hydrogen atoms. So one oxygen and 2 hydrogens. That tells us that these 2 elements are chemically combined in a fixed ratio of, for every one oxygen atom, we have got to have 2 hydrogen atoms to create the compound. Other examples that we might have might be something like CO2, carbon dioxide, which we've also looked at before when we did photosynthesis. So here with carbon dioxide, 1 carbon atom for every 2 oxygen atoms. So again, it would look very similar, 1 carbon atom and 2 oxygen atoms. Okay, so carbon dioxide. So in terms of your test in your exam, they might give you some examples and ask you to tell them firstly whether it's a compound or an element. So if you look at it and you see you've only got one element in there, we know it's just an element, and you can justify that by saying that you know it's an element because although it's got 2 atoms, both of those atoms are identical, there's only one element involved. If you see something like this where you've got more than one element involved, then you can say it's a compound, and you can justify it using the fact that obviously there's more than one element involved in this molecule. You also may get given some more complicated compounds and asked to say what elements are involved and how many atoms of each element are involved. So here we've got sulfuric acid, which is H2SO4. So here we can say we've got 2 hydrogen atoms, we've got 1 sulfur atom, and we've got 4 oxygen atoms. Okay, so if you were going to write this down, probably the easiest way to write it is to say 2 times hydrogen, 1 times sulfur, and 4 times oxygen, and that would be something that you could reproduce in an exam. The very final thing that you might come across with these compounds, so if you're sort of getting up towards the merit level with these questions, is they could ask you something a little bit more complicated, perhaps with a bracket in. Now you have to be a little bit careful with these examples, because the bracket, I guess you have to use it a little bit like you do in math. So I'm just trying to think of an example. Okay, so you may see a bracket in it like this. So the magnesium is on the outside of the bracket, so we've got 1 times magnesium, and that's pretty straightforward. Now what we have to do with the bracket is everything inside the bracket is going to be multiplied by the number outside of the bracket. So we've got 1 oxygen multiplied by 2, so we've got 2 oxygens in total, and then we've got 3 hydrogens inside the bracket multiplied by 2, so 3 multiplied by 2 gives us 6 hydrogen atoms. Okay. So those will probably be the most complicated type that you will come up against, so just remembering that everything inside the bracket is multiplied by the number outside of the bracket.